All right, let's take a look at some exponent problems which we need to resolve by taking the log of both sides, okay? We'll get a few of these that are some of the ones that you see on your worksheet, and then we'll just plug along, okay? So e to 1.75x equals 57. All right, what's x? Okay, obviously we have to take the log of both sides. Now, since this is base e, might as well take the natural log. So I'm going to take the natural log of e to the 1.75x power. 1.75x and the natural log of 57. Okay? I'm going to invoke the power rule now, and I say 1.75x times the natural log of e, which we should identify as 1, equals the natural log of 57. Okay? 57, not 56. Okay? All right. Now, of course, natural log of e is 1, so this just becomes 1.75x equals the natural log of 57. So obviously x is the natural log of 57 over 175. And again, without your calculator, that's fine. Just leave it at that. With your calculator, we go and we find it's the natural log of 57. So natural log of 57 divided by 175. And lo and behold, we get a value 2.31. So x is equal to 2.31. All right. Here we are. 10 to the 3x minus 1 equals 3 times 10 to the x plus 1. Well, there are a couple things we could do. Okay, I am going to be of the persuasion that I'm going to divide both sides by 10 to the x plus 1. And you'll say, why that? Well, because they are of the same base, and therefore we can just subtract the exponents. We get 3x minus 1 minus the exponent of the denominator, x plus 1. Okay, and all we're left with over here is 3. So let's clean this up. Sorry for my penmanship here. 10 to the 3x minus 1 minus x, so that makes that 2x. All right, minus 1 plus minus 1 minus a negative is minus 2 equals 3. Now we can take the log of both sides. Well, what log? Well, base 10, might as well take common log. Log of 10 to the 2x minus 2 equals log of 3. This, of course, just collapses to 2x minus 2 times the log of 10, which is 1, so it's just 2x minus 2, equals the log of 3. Now, again, I could simply solve this for x. X equals the log of 3 plus 2, make sure you do that, over 2. And that's that. Again, I'm fine with leaving that as the answer. That's absolutely fine to leave that as the answer. You want a decimal value, go to your calculator, okay? So going to your calculator, we need log, catalog, log of 3 plus 2, all right? Oh, and then we got to divide that by 2. Okay, so we get 1, 2, 3. It looks like x equals 1, 2, 3, 8, 5. X equals 1.2385. I think I copied. Okay, all right. So those are entry-level problems of that sort. Let's take a look at some that might prove to be a little bit more interesting. Okay, all right. Let's look at this now. I've got 2 to the 2x minus 2 equal to 6 to the negative x. Again, I can't put them on a common base. Got to take the log of both sides. What log? I could take log base 2, but then I'm going to have to go through log conversion, use my calculator. So take natural log. Natural log of 2 to the power 2x minus 2 equals natural log of 6 to the negative x. Right? Okay. Power rule comes in. Every one of these is incorporating this power rule. So we need to know that power rule. 2x minus 2, that collective quantity, times the natural log of 2 equals negative x times the natural log of 6. Now don't get worried. These are numbers. Natural log 6, that's some coefficient of x. Natural log of 2, it again is some coefficient. It's not a big deal. So it can be distributed. So we get 2x, the natural log of 2, minus 2, the natural log of 2. And I might as well bring this guy over because I can see he's going to combine. And that's going to give me what? Well, plus x, the natural log of 6. That's going to equal 0 now. Now I'm going to collect my x terms. Okay? What do I have? I have 2x, natural log of 2, and I have an x, natural log of 6. And I'm going to sweep that 2 ln of 2 to the other side. And here, I'm going to pull out my x as a common factor, and then I'm going to have 2 natural log of 2 plus the natural log of 6 equals 2 the natural log of 2. And now all I have to do is divide by this, okay? And then I'm done with it. Of course, I can condense these, as you can see. This could be x times what? Natural log of 4 plus the natural log of 6, right? Because it's actually natural log of 2 squared, so it's 4, 6. Equals 2 the natural log of 2. This again, then this would be what? X times the natural log of 24 equals 2 the natural log of 2. And okay, so now let's resolve this. This x is equal to what? 2 the natural log of 2 over the natural log of 24. Believe it or not, that's the exact answer. Okay? I'm going to leave it that way. But I know you want a decimal value, so here we go. Okay? So, as a decimal equivalent, just punch it in your calculator. 2 natural log, here's natural log, 2 natural log of 2. Okay? Divided by natural log of 24. 436 equals 4.362. I forgot what that was already. 0.4362. Okay? Yeah, I can't even write it. Sorry. I lost my pen. Okay? 0.4362. But I'd prefer that. Because chances are, the last thing you want to do is pull out your calculator. You want to resolve these as much as you can before you go to your calculator. And in most instances, in all instances, this is the exact answer right here. 2 log of 2, 2 natural log of 2 over natural log of 24. Okay? So I would leave it at that. Okay? Let's take a look at another problem or two. All right? Here we go. 2 to the x minus 6 times 2 to the negative x equals 6. This ought to be interesting. All right, what's 2 to the negative x? It's 1 over 2 to the x, right? So let's take a look at that. That's 2 to the x minus 6 over 2 to the positive x, if you will. All right? equals 6. Okay. Well, now what? I have a fraction now. Okay. I'm going to multiply by the common denominator, which is 2 to the x. So I'm going to get 2 to the x times 2 to the x, right? Multiplying by the common denominator 2 to the x, it gives me 6, minus 6 rather, okay? Minus 6 equals 6 times 2 to the x, all right? 2 to the x times 2 to the x. What do you do when you multiply? You add the exponents. So what do you get when you add the exponents? You get 2 to the 2x, okay? All right, minus, I'm going to bring this guy over, 6 to the 2x. That's a 2 at 2 to the x, not 2x. Careful about that, okay? Minus 6 equals 0. Looks quadratic to me. Do a little substitution. U equals 2 to the x, okay? So therefore, this should be tagged as u squared, okay? Minus 6u minus 6 equals 0. And they got to stick me with a quadratic, don't they? Okay? Well, because I don't see that this is not going to factor. All right, ugly problem, ugly problem, ugly problem. I'm going to abandon it at this because I think I might have copied something wrong. So, but this is the idea, get it to a quadratic. Hopefully I would have had something more factorable, all right? And then I could have just factored it and then recalled my substitution. We'll get another example of that. I'm not going to back out and redo this whole video on these problems because that one bugged me out. It just didn't collapse right. I have to come back to that. Sorry.